Here in question number 5, we are given with a quadrilateral PQRS where the angle P is 10 degrees less than the angle Q and angle Q is 10 degrees less than the angle R and R is 10 degrees less than the angle S. Find the all angles in the quadrilateral. All other angles are comparatively given, but we don't know about the angle S. So we will assume that the size of S is x degrees. It means we can also write that R is just 10 degrees less than the size of x. It means it should be x minus 10. And the size of Q is further 10 degrees less than the size of R. So it will be x minus 10 minus 10. Means we can write it as x minus 20. Means it is 20 degrees less than the size of S. Now, the angle P is further 10 degrees less than the size of angle Q, means we can write it as x minus 30 degrees. Now, if we add all the angles S, R, Q, and P, they all should be added up to 360 degrees. So if I write down the equation, now if I just open the brackets, so I will write down here that x plus x minus 10 plus x minus 20 plus x minus 30 degrees equals 360. So it should be 4x minus 60. Now if I subtract 60 from both sides, I will get 300 on this side. And if I divide both sides by 4, I will get 75 degrees. So it means the size of x is 75 degrees, means the size of angle S is 75 degrees. And other angles can be easily written because we know that R is just 10 degrees less than the angle S, so it should be 65 degrees. Q is further 10 degrees less than R, so it is 55 degrees. And P is further 10 degrees less than Q, so it should be 45 degrees. Now let's proceed to next question. In question number 6, we have to explain why a triangle cannot have more than one obtuse angle. Basically, the sum of angles in a triangle is 180 degrees. So if we consider two angles as an obtuse angles, then the sum will exceed 180 degrees. That will violate the property of the triangle, so it's not possible. In question number 7, Anna says that a square is a type of rhombus, Felicity says a square is a type of rectangle, and Malha says a square is a type of parallelogram. So we have to see that which of the following, like rhombus, rectangle, and parallelogram, has the property of square. Here is the square, and in square we know that all angles are equivalent to 90 degrees and opposite sides are parallel. Now in square properties, we have to see the rhombus. In rhombus, we can see that rhombus also has opposite sides parallel and all sides are equal as well, like square. So it means we can say that square is a type of rhombus. In rectangle, again, all the angles are actually equal to 90 degrees and opposite sides are parallel. So we can also say that square is also a type of rectangle. Now in parallelogram, again, the opposite sides are parallel. So it possesses the property of a square. So it means we can say a square is a type of parallelogram. So we can say that all the statements are correct. Now in question number 8, part A, we have to figure out the coordinates of the other vertex and some of the coordinates of the parallelogram are given. So let's first of all mark the points on the grid. So this is the first point where x is 0 and y is 1. This is the second point where x is 2, y is 1. And this is the third point. And let's join these 2 points. Now in parallelogram, we know that opposite sides are equal and parallel as well. So it means the other side will be parallel and equal to the line which is shown by the purple color. So let's extend this line. Let's shift this line. And that line ends at point where x is 1 and y is 2. So it means that the last vertex of the parallelogram is 1 and 2. Now in kite, we can also mark the vertices here that where is 2, 7, here is 2, 7, and here is 4, 6, which is shown by point B, and here is 5, 7. Let's join these points. So if I join the diagonal in a kite here, actually the other point will have the same distance from the line as point B has the distance. Let me decide the other point. So other point should be marked over here because now it has the same distance from the line as B has the distance. So if I join these points, I will get a kite over here. So it means that the last coordinate exists at 0.48. So here D is actually 48. Now in rhombus, which has some vertices like 4, 5, 6, 6, and 8, 5. So this is the third vertex that is actually shown by point C, 8, 5. So in a rhombus, opposite sides are parallel. So let me keep AB parallel to itself and shift it towards point C. So this will be the third vertex. And if I join the points, so I will get the last point D at 6 and 4, where x is 6 and y is 4. In question number 9, one angle of the kite is 130 degrees and the other angle is 50 degrees. So we have to show that other two angles must have size 90 degrees. So we know that the sum of angles in a kite should be 360 degrees. So let's assume that the other two angles has size 90 degrees means they have same size. So we can assume that other two angles must have size x and x. So if I add all the angles over here, like 130 degrees plus 50 degrees plus x, and this should be equivalent to 360 degrees. To figure out the size of x, let's add the constant terms. That should be 180 plus 2x. We are adding the like terms here, equals 360 degrees. Now if I subtract 180 from both sides, I will get 180 on the right side. And if I divide both sides by 2, I will get the size x as 90 degrees. It means that other two angles have. In question number 10, we are given with an equilateral triangle, ABC. So here we can see an equilateral triangle, and it says that BC is extended to point D. And now if we draw another parallel line that will be parallel to AC, so it will make a parallelogram. So we can draw another parallel line and then we can join point A and E. So we can see that we got a parallelogram. So in triangle ABC, if it is an equilateral triangle, so all angles will be having equal size. So in triangle ABC, all the angles will have same size, means 60 degrees. Now we can easily figure out the size of angle C, means ACD, by using the straight line. So we can take away 60 degrees from 180 to get the size of ACD, that will be 120 degrees. Also, in a parallelogram, we know that opposite angles are same, so DEA will also be 120 degrees because of opposite angles. Now, if we draw a transversal over here on two parallel lines AE and CD, we can see that CAE will be the transversal angle to BCA. So it means that CAE will also be 60 degrees. And we will give the reason that it is an alternate angle. Similarly, the opposite angle to that angle CAE will also be 60 degrees, means CDE will also be 60 degrees because of the opposite angles. Now let's proceed to next question. In question number 11, we are given with a square that is PQRS, and it says that PTS is an equilateral triangle. So again, we can mark all angles with 60 degrees because all angles in an equilateral triangle will have same size. So PTS will be 60 degrees. Now we can figure out these angles like TSR and TPQ. So we can see that these are two perpendicular lines over here, perpendicular sides basically. So we can easily figure out this size means TSR will be 30 degrees and also TPQ will also be 30 degrees because if we subtract 60 degrees from 90 degrees, we get 30 degrees. Now we can easily figure out these sizes of these two angles shown by the green color. So I can suppose that the size of these two angles is x because if we consider this triangle as an isosceles triangle, then the base angles should have the same size. So we can make an equation like x plus 30 degrees. So all the angles should be equivalent to 180. So if we solve this simple linear equation, we get 2x plus 30 degrees equals 180. And if we subtract 30 from both sides and then divide both sides by 2, we get the size of x as 75 degrees. It means that the base angles of this isosceles triangle will be 75 degrees. So here we can show that SRT and STR will have same size like 75 degrees. So on the other side, if we see this triangle TPQ, it will also have two same sized base angles. So these are also 75 degrees. Now we can see that there is a full rotation over here. So in a full rotation, all angles should be added up to 360 degrees. So to figure out the size of QTR, that is actually required angle, we can subtract the given angles from 360. So the size of QTR will be 150 degrees. In question number 12, we have to describe that the type of the triangle we get if we join the diagonals. So in part A, where we can see a kite. So if we draw one diagonal, we get two identical scalene triangles. And if we draw another diagonal, so we get two pairs of identical right triangles. If we see a rhombus, and if we cut with one diagonal, so we get two identical acute triangles. While if we draw another cut over here, we get four identical right triangles. In rectangle, if we draw one diagonal, we get two identical right triangles. And if we draw another diagonal, we get four triangles in which one pair is actually acute triangles and another pair will have an obtuse angles, means another pair contains obtuse angles. In the last one, which is a square, one diagonal gives two identical right triangles and another diagonal will actually split the shape into four identical right triangles. Now, in question number 13, we have to describe the shapes that are made by joining the midpoints of the sides of each of the following quadrilateral. So we'll see that what type of shape we get if we join the midpoints. In square, if we see the midpoints and join them, we get another square. In rectangle, if we see the midpoints and join them, we get a rhombus. In rhombus, if we join the midpoints, we get a rectangle. In kite, if we join the midpoints, we get a rectangle. In parallelogram, if we join the midpoints, we get another parallelogram. And in a quadrilateral in which all angles are different, we can see over here, and if we join the midpoints, we get a parallelogram.